Hello everyone, my name is Steve Smithers. I work for a company called Development Authority of the North Country in northern New York. We are a service provider in the northern New York area. I would like to show you today an example of one of our services called Layer 2 VPNs or L2 VPNs. What you see in front of you is a simulated view of our network provided by a program called GNS3, and each one of these routers is running a separate independent version of code, router iOS. The routers are labeled for either provider beginning with a P or a customer edge beginning with a CE. My PE devices, my PE 1 and 4 are provider edges 1 and 4, and my P2 and P3 are the core routers in the network. Alright, so what we'd like to do, the object of today's discussion would be to show you how we can take a layer 2 protocol. In this particular case, I've chosen IPX as a routing as a protocol to demonstrate how we can, with no interaction in our core, get your layer 2 information from one point of the network to the other. PEs 1 through 4 represent POPs in various towns across northern New York. Alright, so between PEs 1, 2, 3, and 4, we're running a routing protocol, OSPF, in order to distribute IP reachability information to the core routers. I am also running MPLS, which is multi-protocol label switching, between routers 1, 2, 3, and 4 in order to encapsulate your information within a network so that I can move it up to and from without having to act upon the layer 3 or IP information. Between routers PE1 and PE4, we are running BGP, Border Gateway Protocol, to transfer information about customer edge networks. This particular case that isn't being used only because I'm demonstrating a layer 2 VPN today. That comes more into play when we do our layer 3 VPNs, which is something that we also offer. Okay, so if we take a look at, I'm going to show you PE5 over here on the left hand side. I'll bring up a virtual console port for PE5, and whatever I type in here would be just as if I was right in front of the router itself. I'm going to take a look at the protocols running just to show you that the IP routing protocol is not running. I'll issue a show protocols command, and you will see that only IPX is enabled. IPX routing right here is enabled. You do not see IP enabled. Let's take a look at router number 6, just in case. Let's see if it's running over here. Show protocols. IPX is not running on the opposite side either. If you want to, we'll take a look at interface fast Ethernet 1/0, which faces my particular network. Now keep in mind that a CE5 or customer edge router is something that is at the customer site that you configure. Okay, so let's take a look at the running configuration, F10 in particular, and you will see that there is no IP address bound to this interface, and the IPX network is defined right here. I call IPX network 56 or 5 to 6. Okay, easy to remember. Okay, on the opposite side, same happens. Show running configuration. Let's take a look at fast Ethernet 1.0. This side's configured the same way. IPX network 5.6. The reason why I want to show you this is that any layer 2 protocol that you want to move from one edge of the network to the next will be encapsulated, and I'll break it down in a couple of minutes with Wireshark how detailed that packet is. But anything you want to push in from customer edge 5 or 6, in a later video I'm going to attempt to do spanning tree across this particular network. Today to IPX, you can do AppleTalk any other layer 2 protocol. Let's take a look at show interface, show IPX interface, fast Ethernet 1.0, just so we can get the IPX information. IPX network address, network node and address. IPX is a great protocol, by the way. This is the network portion, and this is the node portion. Let me show you something, by the way. In our running configuration, you will notice that on fast Ethernet 1.0, all we defined here is the network. Okay, and if you know a little bit about IP, the network would also need a mask. One of the beautiful things about IPX, and actually IPv6, IP version 6, borrowed this concept from IPX, is all you do is define the network, and then the very last portion, you'll see here, the very last portion of it is the burned in address, or the MAC address of that particular interface. So IPX is very simple to configure in that way. Where we can issue an IPX ping from the opposite side, ping space IPX. And let's take a peek. I will copy and paste the network and address information. And as you can see, the IPX ping is successful from one end to the other. Alright. The program has a built-in capability to capture traffic and decode it with a program called Wireshark. Wireshark allows us to grab packets and actually see what's going across the wire. So I am going to tell my network that I want to start capturing packets on fast Ethernet 0.1, so that when we issue these ping commands, you'll see what actually is going on between the two. I'll minimize this. Try to bring my router customer edge 6 back up. Alright, so let's get some packets moving back and forth. Alright, so we sent 10 or so pings from one side to the next. I'm going to tell my program to stop capturing, make it easier for us to figure out where those packets are. Refresh the screen, and let's see here. How far down do we need to go? Right in here. Okay. So what we have here is we have a packet from PE4 over to PE1. Provider edge 4 to provider edge 1. Here in my Wireshark, what's nice about using loopback addresses, you'll notice that 10.255.4.4, the 4.4 is the source of the traffic, and it actually happens to be a router loopback ID. So it's pretty easy for me to decode these packets and see where they're going from the network. This packet happens to be going from router 4 to router 1. Now, as we decode what's actually going on here, we have a layer 2 frame information for the Ethernet link between routers 4 and 2, okay, because I captured on this particular interface. That is the Ethernet information between routers 4 and 2. Okay, we have a source and destination MAC. Anything you want to know about it, you'll see here that it then puts an MPLS header on that information, and it travels through the network actually encapsulated in MPLS. Okay, so now within that particular header we have a source and a destination of an IP protocol. Then we get down here into my layer 2, my L2 VPN information, and you'll notice down here, right down here in the data, if you look carefully, you'll see right here 56 Charlie Alpha 0 Charlie is the source IPX. I would imagine if we go to CE6 and we do a show IPX interface fast Ethernet 1/0, let's see, that's the destination. Let's see what it's telling me here. That is the destination IPX address. Oh, that's in the data right there. So let's take a look at the corresponding return packet. IPX is built similar in that it has a echo request and echo reply type of a function. In the next packet down, you'll see network 56, Charlie Alpha 0 David as the first 4 of the burned in MAC address. And let's take a peek. Router 6, Charlie Alpha 0 David as the MAC layer information. So what we've seen so far today is the ability to take any layer 2 protocol, okay, that from CE5, customer edge 5 to customer edge 6. That protocol can be AppleTalk, IPX, IP if you would like to see that. This one here is a little bit more fun to demonstrate. And move it from one side to the next, and it is a layer 2 information, layer 2 virtual private network from one side to the next. I appreciate your time. I hope you enjoyed the video.